Hey folks, how we doing? This should probably not be too long a video, kind of a short one. Just wanted to, just a couple little things I want to include. Haven't done a video in a while, naturally, you know, and I want to explain a couple things. I got to remember to address these things as they come up. Those of you who watch my videos, you know, occasionally or regularly or whatever, you will often hear me use the terms Bumblebee Engineering or Bumblebee mentality. Okay, the humble bumblebee, and that's for a reason. Okay, you watched, naturally, I'm sure you've watched my introduction video and this and that, and of course you know well, obviously I'm a very unconventional guy. Okay, kind of do what I want, when I want, how I want. Okay, and that's of course whether people like it or don't like it. I do what works for me. Now the reason I use those terms, Bumblebee Engineering and Bumblebee mentality, because it suits me. And why does it suit me? Well, like I just told you. Those of you who watch my videos again with any type of regularity or whatever probably would imagine I wasn't a great student in school, and I wasn't. But there was one course that I did pretty well in, and that was physics. Not so much in the book sense of the course, but in the lab sense. Did very well in the labs, and you may have imagined that too. And my lab partner, a buddy of mine, he wasn't exactly a great student either, but I guess he was similar to me in that he was much more interested in, you know, doing things, you know, whatever. At that point we were playing with cars and stuff like that, you know, cars and trucks and equipment and this and that. So we did exceptionally well with the labs. In fact, we would not just nail them, we'd hit it with a sledgehammer. We did very well. But I enjoyed the course. I actually can honestly say, of all the time I spent in high school or whatever, and believe it or not, I actually even went to college for a little bit. I have a few college credits. I don't know why. Well, probably to appease my folks or whatever, I don't know. But of all the time I spent, I really enjoyed the physics class. I did, and the fellow our instructor, our teacher, he was a kind of an odd sort, you might say, but he had a way of conveying information that seemed to stick with well, certainly with a person like me. And I actually can honestly say I enjoyed the course very much. I mean, I liked the physics course. And maybe because of his personality or whatever, you know, it had a lot to do with, again, the way he conveyed the information, and it made it somewhat enjoyable. And I remember there were certain things, you know, that you retain, you know, even, you know, all these years later, you know, whatever, 20 some odd, whatever, 20 or more years later, 30 years later, whatever. I guess I'm dating myself with that. But one of the things I remember, we were doing classroom work, and you know, again, being a physics course, he would give you these. You'd be given a formula, and then you would be given situation scenarios. And I remember the way this came up was, I think we were doing something about will it float and will it fly, and you knew the formula, you had the formula, and then he would give you the random, I guess in the form of numbers or parameters, and then you had to apply that to the formula and then see, you know, again, in this particular case is, will it float, or in this case, will it fly? Well, when you got to the point of our humble friend the bumblebee, and you plugged in all the given information, the answer is no. It does not fly. The bumblebee cannot fly. Now, again, as I said, I think this was about 30 years ago, so I don't remember precisely what all that is. In other words, I don't know all the math and science. But something about, I don't know, the wings are too small, the body's too big, there's not enough lift, whatever. But guess what? The Bumblebee doesn't know all that math and science, and quite honestly doesn't give a rat's ass. So the Bumblebee just flies. It just does what it does. Regardless, doesn't know all of that, so it does what it does. So those of you, let me set this down. So those of you who, again, who watch my videos with any regularity, I know you hear me refer to that. I actually was, that has so stuck with me for such a, since that time, that I was going to name, when I originally started doing stuff and decided I was going to be self-employed and this and that, I was actually going to call myself, Bumblebee Engineering and this and that. I felt it wouldn't really resonate, people wouldn't get it, and I wound up getting work, doing work along a little bit different than what I do now, and my work wound up taking me to the 13 northeastern states of the country, so subsequently I decided to call myself Northeast Services, but Bumblebee Engineering would have, I don't know, who knows, if things were different I may have went with that name. So that's the reason you'll hear me say that, regularly and refer to that is because of that. So I just wanted to explain that because a few people have asked, and I just wanted to make that clear as to how that came about, and that was that really is, it was a very important thing. And again, that really stuck with me, and even today. So, like I say, when you see me doing something, again, keep in mind everything you see me doing is done with that mentality. Okay. So that's about it on that. This shouldn't be too long. I just want to show you along those lines. I'm just doing a little bit of lathe work here, a couple little things. I just want to kind of take you over there and show you. I'll do the best I can. I'm not sure if I can set up a tripod to show you most of this. I'll try to keep the bumping and shaking to a minimum. Just a couple little things I figure I'd share with you. Again, you've seen me maybe do some of this stuff already, show some of this stuff or whatever. And again, there's nothing new under the sun. Certainly nothing, real new information here. But again, maybe something some folks will find useful. So that's about it. So I'm going to go over to the lathe. I'll try to bring you over there with me, and maybe I can show you a couple little things that I do. Okay, so we're over at the lathe here, and what I'm making, let's see here, I'm making these discs. Let me zoom in on that. That's all it is, just it's about a 2.5 inch OD. It's got about a 5/8 center hole, and then 3/4 inch equidistant holes on the outside, and it's 3/8 thick. I make these out of I make a fair amount of these. They're, it's a recurring little job. Nothing too critical, obviously. In fact, I don't even bother. I transfer the holes. I put a center dowel in after I do the lathe work, and I put a 5/8 dowel in there, and then I put one on thing on top of it, and I just transfer punch the holes and drill them through that way. And I also, what I make them out of is, it's made out of 70-75 material. And I know, like I say, if it's not a critical part, why is it being made out of aircraft grade aluminum? Because you see this huge hunk, this huge billet here. I make them out of the remnants of what would be the center plug of this. When this comes I get this material. I do this for this job for another shop. I think they said the supplier, I think they said they banned saw it. I'm not sure, or banned, I don't know, whatever. However they cut it out. It looks like it's a sawed operation. I don't know, but they somehow are able to cut out the center and the outside. So anyway, I saved these slugs. And again, they're useful, for doing stuff like that. So that's what I make them out of. So, and again, I make them,
few at a time, you know. So in order to not be, I hate to be wasteful, you know, so in order to not be wasteful, you know, I had to kind of come up with a clever way to, you know, to make use of all the material. And I'm able to get 5 or 6 pieces usually out of this, you know, this 3-inch thick piece. So I had to be a little creative again, you know, when I do all my, you know, when I do all my lathe work and how I'm going to set it up to, you know, because I want it kind of, you know, kind of accurate. So I try to do it, you know, without removing the piece. You know, I hold it near the end of the chuck, you know, and then I drill it and this and that, and then I part them off. So I guess a couple of the things that I just wanted to touch on was when I part, let me turn this light on here. This might help here. Okay, well, nah, I don't like it. Nah, I like it better without that light. Okay, so again, just a couple of things. Again, not that it's new information, but what I do is here's, when I part, again, and I'm just using a regular high-speed tool. Let me zoom in on this. When I do my parting, that's not going well, is it? Okay. When I do my parting, most of the times, I part off, I grind the tool in such a way here that as I'm grinding the tool, because it's just a high speed steel, you know, regular lathe, you know, parting tool. I grind the tool in such a way that, you know, when I'm going into the wheel, I go straight to make sure I've got a nice sharp, you know, nice sharp edge, because that's all I do to it. I don't get carried away. I know some guys do other things to it. I don't. I never have. But what I do is, as I'm grinding it, I tail it off this way. I take the back of the tool when I'm almost, you know, when I'm done, and I just kind of go that way. I tail the tool, the ass end of the tool, I tail off to my left, which, again, I'm sorry I'm having a difficult time getting this to focus, but what that does is it leaves, here we go, that might be a little better. It leaves this side of the tool a little bit longer than this side of the tool. The tail stock side of the tool a little bit more than the chuck side of the tool. And this, and I square the tool. I do square the tool up against, you know, up against the face of the work. But because this side of the tool is a little bit longer, the tailstock side, the part that you're parting off, it generally doesn't leave that nub, or it leaves less of a nub than just going in completely square, or, you know, not having yourself, you know, or you know, naturally, if you're, depending on what you want to do. I mean, if this part here that you're holding in the chuck is going to be the usable part, you might want to tail it that way. But most often you're parting off, and the part you're parting, you know, you want to, you know, you want to use the part on the tailstock end. So that's why I grind that. Like I said, I leave it a little long so that it's, you know, it's going to cut before this end of the tool. So that's one thing. And then secondly, on this particular job, well, you can see and you can see on this the results of them. Let me zoom in here. Here's a part that's just been parted. I haven't, you know, done any dressing on this yet, any facing or anything. But I'm going to now, because I've left them about, I don't know, 30 thousandths or so long. Now this thing is essentially only 3/8 thick, so, you know, again, holding this, you know, to get it, you know, to get it faced off on this side, you know, is a little tricky. So what I'm doing here, yes, I guess I could set this up and put an indicator or whatever, but what I do is I'm sure you've seen me use this tool. I'll bring you back in a second here. Let me get this set up. Okay, so again, my parting tool is still in here. So all I'm going to do now is I'm going to take the parting tool out. And I'm sure you've seen me use this tool in some of my other videos. And again, this is not my idea. I've seen this. I know I've seen other guys on YouTube use it. remember, I don't know, a while back, I think I read about it or something on a forum, or I saw some pictures, so I decided to make one. Normally, it's just a piece of flat bar, you know, with the bearing through it, and then you would hold it, you know, in a tool holder, you know, or whatever. But I chose to just make mine this way. I felt it would make it more versatile. You can use it this way facing, or you can take it off and use it this way, you know, for a turning. And again, you have, you know, full range of you know, movement up and down on here. So in this case, I'm going to use it this way, because this is going to be a facing situation. And again, the whole idea of this thing, in my opinion, is to be expedient. You don't want to be messing around with indicators. You don't want to be, you know, so I'm just going to take this thing I can't do it obviously holding the camera, but I'm just going to take this thing and center it onto here by eye. You know, I'll have the lathe running, you know, and I'll put the thing on there and I'll just center it by eye. And then of course I'll bring my handle around and clamp it down. And then of course I'm going to touch the bearing into the work and get it to, you know, run relatively true. And relatively true is good enough for a case like this. We don't need, the whole idea is not to have to set up, it's to be expedient. Not to have to set up the indicator to, you know, to get this thing within half a thousandth or a thousandth, because it's not that big a deal. Whatever it is that they're gonna bolt this thing to, as both faces are going to be flat, no question about that, because they're going to be faced off, and it's going to be true by eye. So whatever they're bolting this to, it's going to be fine, because they're just going to put 1/4-inch bolts through there, and it's going to be great. Any amount of difference will easily be taken up in the relief of the holes. So again, the precision just simply isn't required on. So for something like this, again, I feel it's an ideal situation to show you what, you know, the use of this. So anyway, let me, I can't do this all with one hand naturally, so let me try to get this set up somehow, and I'll bring you back for what I'm going to do here. Okay, so I've got it set up now. I've got my tool set up here, and obviously what I'm going to do is I'm going to take the bearing and I'm going to push it into the, you know, into the face of the, now I've got that in the chuck. It's not crazy tight. It's just kind of, you know, it's just in there, and it's not, obviously you can see, it's barely grabbed in the jaws. It's not being held all that much. It's just barely, you know, barely holding on there. And again, it's not crazy tight. So let me try to show you how I'm going to do this. Okay, so there we are. And now I can do this without too much craziness here. Okay. All I'm going to do is just going to bring this up. And I do this almost towards I have the bearing almost towards the edge, the outer edge of the part. And I'm just going to run it up. And I'm going to touch it. Okay. And there we go. I'm going to put a little pressure on it. I'm just going to walk it in. And before you know it, look at that. We're in pretty good shape there. We're running pretty darn true. So with that, all I'm going to do now is I'm going to shut it off, and I leave the bearing up against it. I leave it and I let it coast off. And then I'm going to take my chuck wrench, kick myself into neutral here, and I'm just going to start tightening on my chuck a little at a time. Again, I'm not going crazy here. Trying not to be too much in the shot either. Okay, a little at a time, socking them all down. Okay, so now I've got it to the point where I'm pretty satisfied that it's pretty well socked down on there. Now I'm just going to back it away a little bit, and then I'm going to start the lathe, and I'm going to bring the bearing up to it again, just to see how we did. Here we go. Oh, yeah, better put it in gear, Mike. There you go, Einstein. Okay. Okay. Now, I mean, it looks pretty darn good. So, just going to confirm it. I'm just going to bring it up, touch it again, take it out. Actually, I'm going to back it out this way a little bit. I'm going to bring it back out, bring the compound out. Cross slide, I'm sorry. And I'm just going to touch it. And that's it. We're good. Taking it away. And if you look at that, my goodness, that thing is pretty much running dead on. No, I'm not going to indicate it, because the whole idea of this is that you don't have to indicate, because again, there's nothing super critical here. And then what I'm going to do is I'm just going to go ahead and face the part off. And then that'll be it. I'll face it to width, and we'll be good. So I'm sure you don't need to watch me do that. I'll bring you back in a minute. Okay, maybe you can watch me. I'm just gonna face this thing off. I got you set up on the tailstock there. I have a little magnetic thing here. All right, so I'm gonna need to take about 20 thousandths off of this, or well, a little more than 20 thousandths. And that's about it. You can see where the bearing was right. Maybe, let's see, let me just zoom in there. I hope this will work. There we go. You can see the ring around here where the bearing was riding on it, right? Right around the outside here. Okay. And again, not important, because I'm gonna face it off. So let me kind of pan out a little bit here, and you can watch me. I'm just gonna face this thing off. I'll probably do it in a couple of cuts, and then I'll show you how this all works. Put myself in gear. And again, just with the calipers, I'm just going to check it, because again, we're not doing any NASA work here. We're just going to make these little flanges. All right, so 78, and boy, 79. Look at that. Just by doing that, 78 and a half by the caliper, not by a micrometer. But boy, we're within, you know, we're within a thousandth of being concentric on all three spots. So, you know, I think we're in pretty good shape. So let me take my final finish cut here on this, and we'll be good. And again, we're just going to do this by caliper. Well, what do you know? 73, 71 and a half, 72. Boy, that's pretty good, isn't it? So now, what I will, again, not that it's, this of course naturally I have a sharp edge here. I'm just going to touch this gently with a file. Not that this is the finish actually, but I just don't want to cut my hands. I'll show you what else I'm going to do after this. So let me show you here. That's it. And again, go easy with the safety Nazi crap, because A, I don't give a, I don't care, and B, if you'll see, this is a tapered file, and I put it against the jaw, so it's not going to get sucked into the jaws. And of course, I have a huge handle on the end of this. So again, I got it. I know what I'm doing. Okay, now I will take the part out, and that'll be that. I got a couple more to do, so let me finish facing them all to length, and then I'll show you what one other little thing that I do, and I'll show you how that'll work out as well. Bring you back. Let me just try to show that to you one more time for clarity here. Where I'm going to be looking, let me zoom in here. Where I'm looking, you can see the amount of wobble. Again, I just put it in the chuck and lightly tighten it. My finger's right here. Where we're going to be looking, where we're concerned with, is going to be right where my finger is to see how it's going to straighten it out. So, again, doing this one-handed, but let me try to zoom in on this. And again, we're out near the edge of the part. Okay, we're touching. And all I'm going to do now is just feed in. That's all I'm going to do. And there we go. Okay, and you can see now, look at that. Boy, that's pretty consistent. That is looking pretty good. And again, I'm not going to move. I'm going to leave it where I'm going to leave the hand wheel where it is, and I'm going to leave this I'm going to leave the wheel where it is, and I'm just going to go and shut the lathe, and that's it. Okay? And again, I leave that on there, and I let it just keep turning with the bearing. Okay, the bearing is still on it, and then all I'm going to do is I'm just going to start tightening a little at a time, round and round. And again, I'm not killing it, because A, it's an aluminum part, and B, it's just not necessary. Again, I'm doing this one hand, so please bear with me. But that's pretty good. So now, all I'm going to do now that I've got it that way, now I'm going to take it and I'm just going to back it off slightly. So there's now a gap in there, and then I'm going to start the lathe again, and I'll see how it looks. And then once it's running, then I'll just bring it in and touch it up again, just to make sure I'm getting that consistent running, that consistent sound on the bearing, that it's not going thwap, 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 that I'm getting an even sound on there. So okay, here we go again. So you can see, I know with the motion it's difficult, but it looks like we're running pretty darn good there. It looks dead on to me. But again, just for shits and giggles or whatever, I'm gonna I move it. I back the cross slide out to me just a little bit, so I get further to the edge of the part. And again, I'm just gonna go ahead and run it in, run the carriage right up to it, and you can see we have that very consistent sound, very even. So that satisfies me. We take it away, and again, it is obviously, looking at it by eye, that sucker is dead on. So I just wanted to maybe clarify that a little bit more. Okay, so again, I got a couple more of these to do yet, and then I'll bring you back, and I got one other thing I'm going to show you. Again, not that it's a new trick or anything like that, but just figured maybe be useful for somebody. Okay, so on to the next step here. I know I'm sure if you've watched even my last video, you've heard me say that I don't like chucking on finished parts, and I don't. Normally, because especially on an aluminum thing, you would think it's going to put all kinds of geep marks and stuff in here. This one doesn't have any. Geez, let's see. Boy. This doesn't have much either. Maybe a little bit over here. Boy, not much of any. Well, bad example, but I purposely, here, let's see. Is that working here? Yeah, I purposely left these. These finish up, the finished part here is 2.5 OD. I purposely left these a bit over on the OD. And that's because, again, as I planned the job out, I knew I was going to have to face them off. I knew I wouldn't be able to part them off at exactly 3/8, so I wanted to part them off a little long and then put them back in the chuck and face them. And again, I knew I was going to have to exert quite a bit of pressure on them, and it is aluminum, so I figured I was going to have a lot of marks on there. In this case, as it turned out, I didn't, but assuming I did, so I left, you know, quite a few, about, I don't know, 40 thousandths over on the OD of this thing. And the reason I did that was so that I'd have room to turn them off. Well, now, how am I going to hold them and turn them off, you know, without an arbor or whatever? I mean, yes, I could make an arbor and do all that, or I could do this. I think I may have heard this referred to as pressure turning or something to that effect. I'm not sure. But essentially, what I've done, what you do, is you take a piece of stock. In this case, it's hollow because I'm going to have the center come up and I want room. The center is going to hold the part and it's going to pierce through it. So what I do anyway, again, I don't know how everybody else does it, but what I do is I put a piece of material in the chuck, and I chuck it quite tightly because again we're going to have a lot of pressure against this thing. And then what I'm going to do is I'm going to make a facing cut on it. But what I'm going to do as I'm making the facing cut, another reason I always leave my compound at 90, I get a lot of advantages out of this. This is just one of many. As soon as that tool touches that face, touches here and begins facing that way, I'm going to be here, and I'm going to very slightly and gently twist this thing clockwise so that the tool, as it comes in, is going to be making kind of almost a diagonal cut. That means, in other words, it'll be cutting more as it progresses than it was out at the edge. And obviously you can see where I'm going with this. This way the larger, you know, the diameter will be larger on the outer part of the ring than on the inner part of the ring. And that's the purpose of that. So again, so that when I do this, again, this piece is going to, again, I'm doing this with one hand, sorry about all this shakiness and such not, but what we're going to have here is a situation like this. Yeah, sure, Mike. Okay, where this is going to be held on here, and then this is going to hold it. Now, and this, of course, is going to be, the tailstock will be applying pressure, and I'm going to be coming along here and taking off the OD. And again, you're not going to take heavy cuts on this. I'm just going to go very, very light cuts, maybe 10,000 at a time, just to take the material off. And again, it's not that critical. And then it should be fine to hold it. And again, I'll break the edges, you know, with a file. You know, and I have pretty good access to do both sides at once, or, you know, whatever, a little piece of sample, whatever the case might be. In this case, I think just a file will be fine. And then that'll be it. So again, we have the pressure against it this way, and then the tailstock with the live center is holding it this way, and it should be fine. So let me show you how I'm going to do that. Again, I'll retract this, and then I'll show you what I mean insofar as, you know, I'll show you how I'm going to set up and take the cut on here, and then set one of these up and show you how I'm going to do it. I'll bring you back. Okay, so here we go. I've got the tool all set, should touch, and then as it begins to face, I'm going to let the feed go automatically. I've got it set at pretty much the slowest feed I can. But as it begins to touch, I'm just going to very, very gently, as it's facing, I'm going to very gently crank the compound just a little bit so that it's cutting more as it goes than when it started. That's all. So, I'm not sure how should you want to watch it. Yeah, I'll show you here. And I'm just going to back this out. Give me a moment to start. And here we go. And then as it touches, it's touching, so now just very, very gently, but consistently cranking the tailstock, the compound in. That's good, and we're done. Okay, so technically now, this piece, let me crank this out of the way. So again, technically now, you can see the chip actually got larger as I did that. Again, though I only went about 20 or 30 thousandths on the compound. this now is a larger, oh boy, it's larger here than it is here on the inside. So again, all the pressure hopefully will go to the outside. And again, it'll, create a little pressure on the part, which is fine. And, maybe give it a little gripping or whatever. I'm just gonna clean the inside of this. I'm not gonna get too crazy as far as, any deburring, or I'll take the burr off, but that's it. Nothing crazy. And that's about it. And then I'll set it up the way I show you, and I'll do a part. Bring it. Okay, so here's our setup. Like I said, we got our piece here nice and tight in the chuck. We've got our center that's going to come through our the hole in our piece here, and so that's essentially all we're going to do is just put that on there, and then the center will kind of just kind of locate it for us, and then we just tighten it down. And with the again, I'm putting pressure on it with the the crank on the tailstock. And then that's it. As it naturally, as we turn it, it will, it will drive. And of course, we got to take very light cuts naturally. And I guess, like I said, I've got about 40 or so thousandths to come off of that. So, so that's where we are. So, I'll try to bring you back as I'm doing some of this. Okay, so here is from a different view. Here's my setup. Again, we're just gonna just going to go like this, and again, the tool will come and just gently, again, you can't take heavy cuts, of course. Just take very light cuts, 10 thousandths or so at a time. Again, not a big deal. I've only got about 30 thousandths or so to come off of this, and I've even, again, back here, I keep this on here. This is permanently, I've made a bracket and stuff to fix this. What I've done is when this will come around, my finish diameter will be when it comes to the 0 on the indicator, and you can see how that's rigged up to touch against my. Oh boy, let me zoom out here a little bit. I've got this rigged up so that it works off of my as the cross slide intersects it. It works that way. So, like I say, I've got it set up now so that my finish diameter will be when I hit my 0 there. So let me try to set this back up on the tripod, and you can watch a little bit of this. Okay, well, here we go. Just got the piece in there, taking a very light cut. Like I say, just about 10 thousandths or so at a time. Nice and easy, coming along. That's it, goes to the stop, set it back. I'm actually able to read, I know you can't see it in the frame, but I'm actually reading off my indicator in the back now. Take another 10, come in for another cut. Again, nice and easy. Periodically just check the handle on my tailstock, make sure it's exerting pressure on it. Kicks out, take it back, more. Okay, another nice light cut, that's about 10, 12 thousandths. Okay, that's that. Away, over that. And now we'll come in and make my final cut. That's about 8 thousandths. And there we go. This will be our final cut. Okay, that's it. And we'll back this off. And then all I'm going to do, I'm just going to take a regular file, naturally, and I'm just going to hit on this side and this side. There should be a trick trying to do this around the camera. Okay, well, let me just check that. That feels good. That feels good. Okay. That's about it. Now all I do now is just release the pressure on the tailstock, take the part out, and there it is. One finished piece on the OD. As you can see, and again, if you don't go crazy, let me just zoom this out a little bit. If you don't go crazy, you know, and if the thing doesn't spin and you know, you're not taking such heavy cuts that you're forcing it to spin, it doesn't really, I mean, this is aluminum and it's not even, you know, that drive disc didn't even really leave any marks on it. So, you know, and you know, let's get our calipers here and see what we got. I don't know how with the glare and everything, but yeah, look at that, we're a thousandth over. So that's it, we're 2,500 and just about half a thousandths over, according to the caliper, again, which is fine. This is not a precision piece. So now we're good. We've got everything, our two faces, our width is good. My hole, I'll deburr the hole with just a little chamfer. I can do that on the drill press or whatever. And then I'll come back and again, I'll just use my template and I'll put a dowel in there and put the, put the holes in there for the, I'll transfer them, you know, do it with a transfer because again, it's not that critical a thing. So again, another little, you know, just a little thing that I do, again, just to save some time, you know, Expedient, it works, you know, it works for me and I like it and it's just something that I do. So there we go, and one more finished disc and that's about it. Okay, bring you back in a second. So, I guess that about covers it. Like I said, I just wanted to, you know, go over a couple of those things. I wanted to explain about the, like I said, about the whole Bumblebee Engineering thing. Again, I just wanted to show, again, not that there's anything new here. I'm sure you know, most people know this. But again, I just wanted to show about, you know, again, with my parting thing with the parting tool, my bearing, my bearing tool for lining up small flats in the chuck when holding. And again, that little deal about turning ODs on small flat discs. I'm not sure, I think I may have heard it referred to as pressure turning or something to that effect. Again, that's my little method of doing it. Again, not that I'm able to teach anyone anything here, you know, just my ways of doing it. And again, maybe it'll help someone. So that's about it. You know, that'll wrap it up here. Again, just wanted to make that little short video and that explanation. And that's it. And just to say, don't forget the humble Bumblebee. All right. Anyway, thanks for watching. And as some famous guy once said, everybody polka. See you next time. Oh yeah, by the way, no insects were harmed in the making of this video. I found this guy dead on the windowsill of the shop, so, you know, what are you gonna do? I figure. But hey, I'm recycling, you know? I mean, he was dead, I'm using him to make a point, so, I don't know. Just figured, you know, it was a good opportunity. But like I said, no insects were harmed in the making of this video. See you next time, folks.